Okay, today we are learning a new section. We're learning 1.3 arithmetic sequences. So we've actually seen arithmetic sequences already. We just didn't realize it yet. An arithmetic sequence, which is sometimes called an arithmetic progression, is just a sequence in which the difference between each term and the preceding term is always constant. This means that we're adding the same number to it each and every time. So going from the first term, u sub 1, we add a number to that to get to the next term, say 3. That was an ugly 3. And as long as we add that every time, that makes it an arithmetic sequence. So example 1, arithmetic sequence. So now we need to find if the following sequences are arithmetic. If so, what is the difference between each term and the term preceding it? So in order to find this out, I need to check and see if the difference between each term is the same. So 14 to 10 means I subtract 4. 10 to 6, I'm subtracting 4. 6 to 2, subtracting 4. And 2 to negative 2, subtracting 4. So just based off of this, I would say that this is yes. Each term has the same difference in between it. Now, when I started this, I said that I had to add the same term each time, but these are all subtraction. So how is this an arithmetic sequence? Because subtracting 4 is the same as adding negative 4. So that's what makes this one arithmetic. Let's look at the next one. If I look at the next one, going from 3 to 5 is a gain of 2. Going from 5 to 8 is a gain of 3. So I can automatically shut this down as an arithmetic sequence because it gains different numbers each time. This was plus 2, this was plus 3. If I look at this one, it's plus 4, plus 5, and so on. So automatically know that this is not arithmetic. In an arithmetic sequence, u sub n, now we see the curly brackets in the u sub n. That means that it is a sequence. So that's how we show that something is a sequence. U sub n equals u sub n minus 1 plus d for some constant d and all n greater than or equal to 2. This is one of those things that we did last time. Remember, u sub n just stands for a number. So u sub n just stands for a number. And u sub n minus 1 stands for the term that is before that number. So if I'm looking for the 10th term, n would be 10. U sub n minus 1 would be 10 minus 1, which is 9. The d is a constant, which means some number that does not change. And this has to be true for all n greater than or equal to 2. So for every term greater than or equal to 2, this will be true. So the number d is called the common difference of the arithmetic sequence. It's the number that is going to be added to each term. Okay, so example 3, graph of an arithmetic sequence. If u sub n, remember that's in the curly brackets, it shows that it's an arithmetic sequence, with u sub 1 equals 3 and u sub 2 equals 4.5 as its first two terms. So A, we have to find the common difference. In order to do that, I can just do 4.5 minus 3. And that gives me 1.5. My handwriting's a little worse today. I'm trying a different method, so let's see how it works out. So far, not as great, but we'll just have to deal with it. So that's my D. My D is 1.5. Write the sequence as a recursive formula. So remember, when I'm writing something as a recursive formula, it is going to be u sub n equals u sub n minus 1 plus the common difference, which is 1.5. So as my recursive formula, to find each of the next numbers, I have to add 1.5 to it. Give the first 7 terms of the sequence. So that's going to be 3, 4.5, 6, 7.5. Ew, that one's ugly. 9. That's 1, 2, 3, 4, 5, 10.5. Maybe. And 12. Okay, so that's parts A through C. Now part D says to graph the sequence. So then in order to graph the sequence, I'm going to go onto Desmos. And I'm just going to start plotting my points. My first point was 1, 3, because it was the first term, which was 3. Then 2, 4.5. Then 3, 6. Then 4, 7.5. Then 5, 9. And we had to do 7 terms. 6 was 10.5. And 7, which was 12. So if I look at my graph now, I want to kind of see what shape this makes. And when I look at it, I can automatically see that this is forming a straight line. That should tell me something about arithmetic sequences. As I work through arithmetic sequences, I should generally see a straight line. As a matter of fact, if I graph the sequence, I should always see a straight line. Without that, it's not going to be an arithmetic sequence. So that's just another way to tell whether it's arithmetic or not. Okay, so the recursive form is nice because we can start with the first term. We can add something onto it each time and get the next term. And that's really convenient when I say like something like find the first 7 terms. What if I told you to find the 150th term? Well, then that means that you're going to just keep writing the terms out. Believe it or not, one time I was tutoring somebody for the SATs, and we were in a situation like this. And as we're sitting at the table, this girl was working on her problem, and the goal was to find the 500th term. And she wrote out all 500 terms. She found the right answer. But on the SAT, it's obviously a timed test. So she wrote out 500 terms of a sequence, which took up about 10 minutes of her time. So she got one question done in 10 minutes. You need to move at a much faster pace. So that's where the explicit form comes in and makes it a lot more convenient, is whenever we have to find a big number. In an arithmetic sequence, u sub n with a common difference d, then we can find u sub n by making it equal to u sub 1, or the first term, plus n minus 1, so the number before the one we're looking for, times d, which is that common difference. And this will work for every n greater than or equal to 1. Again, this formula makes it so that if I have to find the 1000th term, or u sub 1000, I don't need to know u sub 999. I don't need to know the term before 999, so that I don't have to find every single term before 1000. Excuse me. Find the nth term of an arithmetic sequence with first term, and I'm supposed to have a number here, and so I'll start with 7, and a common difference of 3. So when I write this out, it's going to be u sub n equals the first term, 7, plus, and then we do parentheses, n minus 1 times common difference is 3. We can do better than that. So 7 plus n minus 1 times 3. There's certain things I can do here. If I wanted to simplify this, because I'm going to have to distribute this 3 to both the n and the negative 1, I could do u sub n equals 7 plus 3n minus 3. And then I could combine my like terms, the 7 and the 3, and get u sub n equals 4 plus 3n. And now that'll work for every number greater than or equal to 1. So if I wanted to make my u sub n now u sub 2, just to show off the fact that this formula will work, all I have to do is plug a 2 in here for n. 3 times 2 is 6, plus 4 is 10. If we went up to our original here, first term 7, common difference of 3, then we could have said 7 plus 3 is 10. Like I said, that's beautiful for u sub 2. But if I want to find u sub 100 now, I don't have to list out 100 terms. 3 times 100 is 300, plus 4 gives me 304. And that's my final answer for u sub 100. So that's where using the explicit form really helps you, is as we look at these big numbers. Okay, I want you to try this one on your own. See if you can find the 45th term of the arithmetic sequence whose first 3 terms are 5, 9, and 13. So first I'm going to find my explicit form. U sub n equals, and then u sub 1, which is 5, plus n minus 1 times, now what's my common difference? 9 minus 5 is 4, 13 minus 9 is 4, so that's my common difference. Now I'll distribute the 4. That gives me 5 plus 4n minus 4 combine my like terms, the 5 and the 4. That gives me 1 plus 4n. Now I'm trying to find, and that's u sub n. Ooh. That's u sub n. So to find u sub 45, I would just do 1 plus 4 times 45. Now, order operations tells us that we need to do 4 times 45 first. Everybody knows that's 180. So 180 plus 1 gives me 181. And that's my final answer. Okay, I'm going to give you plenty of practice on these, both writing the recursive and explicit formulas and finding a certain term.